Wow, I'm here to surprise you with the world's first artificial intelligence-driven autonomous underwater vehicle. Wow, this is something revolutionary. Beam said it had achieved a groundbreaking milestone by deploying the vehicle to inspect wind turbine jacket structures at the Seagreen offshore wind farm in Scotland. Join us amazing technology and AI advancement journey by subscribing to our channel today. This automation can revolutionize how we carry out inspection and maintenance of offshore wind farms, helping to reduce both costs and timelines. Looking ahead to the future, the potential of this technology is huge for the manufacturing, automotive, and telecommunication industry, and success in these initial projects is vital for us to progress and realize this vision. Marine robotics company Beam was formed last week through the merger of high-tech offshore wind service company Rovco. By using advanced AI, vehicles can perform complex underwater tasks with no human intervention, significantly boosting the efficiency and cost-effectiveness of underwater inspections and surveys. Offshore wind farm inspections are typically manual and time-intensive, but this AI revolutionary vehicle can let offshore workers concentrate on the more complex elements of their roles. It reduces inspection timelines by up to 50%, which in turn cuts operational costs, drastically improving inspection data quality and enabling 3D reconstruction of assets alongside visual data. Now, explore how it works. First, data collection. High-resolution optical and thermal cameras capture detailed images and videos of underwater structures like turbine foundations, cables, and mooring lines. Sonar is used for mapping and detecting structural issues. Sonar systems provide 3D models and bathymetric data of the seabed and infrastructure. These sensors measure variables like pressure, temperature, and water current, providing contextual data to understand inspection conditions. Finally, acoustic sensors detect sound emissions from turbines and underwater equipment, potentially identifying mechanical issues. Second, data alignment. Before the AI can analyze the data, remove noise, irrelevant data, or artifacts that might distort the analysis. Synchronizing data from multiple sensors to ensure consistency and alignment in time and space. Third, AI and machine learning analysis. AI uses pattern recognition to identify specific structures and potential defects, such as cracks, corrosion, or marine growth on turbine foundations and cables. Machine learning models are trained on historical data to recognize patterns associated with healthy infrastructure. The system can flag deviations from these patterns as anomalies like damage and erosion. Sonar and camera data can be used to create detailed 3D models of the underwater environment. AI helps to process and align the data, offering a visual representation of potential problem areas. I hope you enjoy this video. Take care.